Have you ever thought about whether you could teach a computer to write just like your favorite author? Well, that's exactly what we're going to try to do today. We're on a mission to train an AI, let's call it a John Green bot, to mimic the one and only writer John Green. But as you're about to see, it's not quite as easy as just feeding it a bunch of his books.
Okay, so this is what our bot sounds like right out of the box with absolutely zero training. It's a random string of words. Not exactly a thoughtful Vlogbrothers video, is it? It's more like a word salad. Clearly, our little bot needs some serious help. And the solution is found in a field called natural language processing, and we're going to walk through exactly how it works.
So how in the world do we fix this jumbled mess? Here's our game plan. We'll start with the big picture challenge, then we'll get into the details of prepping its digital diet and actually training the AI. After that, the fun part, the grand reveal of what it can write. And finally, we'll put the machine and the human head to head. Let's get into it. First up, the bot writers challenge. You see, the real problem here isn't just about writing code. It's about teaching a machine the patterns of human language, all without it ever actually understanding what any of the words really mean.
You know, when you get right down to it, our AI is basically playing a very, very sophisticated game of fill in the blank. We can give it a prompt, something simple like good morning, and its entire job, its whole purpose, is to predict the most likely word that comes next. It has no idea what morning is, but from seeing thousands and thousands of examples, it learns what words usually follow it. It's all about recognizing and just replicating patterns.
So that brings us to our 4-step mission. First, we have to gather and clean up all the data. And in this case, that's all of John Green's words. Second, we set up the AI model, which is kind of like building the architecture for its brain. Third, we train it. And finally, the best part, we ask it to make some predictions and see what it can actually write for us. Okay, let's kick things off with step 1, its digital diet. See, before an AI can learn anything, its food, the data, has to be prepared just right. We've got this huge text file with John Green's speech from Vlogbrothers subtitles, but a computer can't just read it like you or I would. It has to be processed first.
And the very first part of that whole process is something called tokenization. It's a really simple but absolutely crucial step. We just break down every single sentence into a list of its parts. Every word, every comma, every period. These little individual pieces are called tokens. And here's what that looks like in action. Let's take the classic sentence, "Good morning, Hank, it's Tuesday." Now, tokenization doesn't just split the sentence by the spaces. It's actually smart enough to separate the word Hank from the comma and Tuesday from the period. It even breaks a contraction like it's into 2 separate tokens, it and is. This gives the AI much cleaner, much more consistent data to learn from.
But, this process brings up a pretty big problem. After we tokenized all of John Green's words, we found nearly 10,000 unique words that show up only one time. I mean, think about it. How can an AI possibly learn the pattern for a word like zombie corns if it only sees it once? The short answer is, it can't. These rare words are a huge hurdle. So we have to clean the data even more, and we use 3 key techniques. The first one is called stemming. That's where we basically chop off common endings like ed and ing to group similar words. Second, we simplify things by replacing all numbers with just a single pound symbol. And third, we take all those 10,000 rare words and replace them with a special token UNK, which just stands for unknown. This lets the model handle words it's never seen before without completely breaking down.
All right, our data is all prepped and ready to go. So now we can move on to the really cool part. Building and training the AI's brain. This is where we actually construct its core architecture and kick off the learning process.
So the AI's brain really has 2 main parts. First, there's something called an embedding matrix. Just think of it like a giant dictionary that turns every single word into a unique list of numbers called a vector. And what's cool is that words used in similar ways get similar vectors. The second part is a recurrent neural network, or RNN. This network is what reads those word vectors one after another in sequence, building up a kind of summary of the sentence's meaning so it can predict what comes next.
Okay, so how do we actually know if all this training is working? Well, we measure its perplexity. And you can just think of perplexity as a score for how confused the model is. A really high score means it has tons of different options for the next word and no idea which is best. A low score means it's getting much, much better at predicting. Our whole goal here is to get that score as low as we possibly can.
And you can see the results of all that training right here. When we first started, the model's perplexity was way up over 300. It was super confused. But after training, it dropped to below 50. I mean, that is a huge improvement. The bot is getting way less confused and a whole lot more confident in what it thinks the next word should be. And that, my friends, brings us to the moment of truth. Step 4, the grand reveal. After all that data cleaning and training, what can our John Green bot actually write? Let's find out. So if we tell the bot to always pick the single most probable next word, this is what we get. And hey, it starts off perfectly. Good morning, Hank. It's Tuesday. But then it just gets stuck in a loop. Why does it do that? Well, because statistically, after the phrase, I'm going to be like, the most probable next word is I'm. So it just keeps repeating itself. It's technically correct, but man, is it boring.
And this actually reveals something really important. Great writing isn't always about picking the most obvious word. To make our bot more creative, we have to allow it to sample from a wider range of possibilities. Not just the number one most likely word, but maybe the second or third most likely too. This adds a little bit of randomness into the mix and helps it generate way more interesting sentences.
Okay, on to our final section, human versus machine. Because even with these creative little tweaks, the bot's writing still isn't John Green. So what's the missing piece?
It really comes down to two big hurdles. First, we still had limited data. Remember those 10,000 rare words we had to just throw out? The bot never even got a chance to learn their patterns. But the second issue, and this is the much bigger one, is that the bot has no true understanding. It's an incredible pattern matcher for sure, but it doesn't get meaning or context or who its audience is.
And that right there is the fundamental difference. A human writer, like John Green, writes with this deep, rich understanding of the world, of his audience, and what he wants to say. Our AI is just predicting the next most statistically likely token in a sequence.
So this all leaves us with a pretty fascinating question to chew on. As these AI models get more and more sophisticated, they will absolutely master the patterns of language. But can a system that's built entirely on probability ever truly master meaning? That's definitely something to think about. Thanks for joining me on this one.